All right, it is 6 o'clock. Welcome to our last lecture. We have some students joining us online, some students here in person. Welcome both group of students. Okay, before we start, I will start with some logistics, and then I open it up for questions. After that, I will deliver lecture, okay? Can somebody for online confirm that you can hear me and you can see my screen?
I can hear and see your screen.
As well.
Hello?
Oh, yep. Hello?
Can some students online confirm you can hear me and you can see my screen?
Hi, I can hear you as well as I can see you.
Thank you, Riley. Great. Thank you, Logan. Thank you, Alexandra. Thank you, Gabriel. Great. So, some students have questions about your test mark, test 1 mark, test 2 mark, online assignment mark, written assignment mark. All the questions about your marks, please address directly to our course coordinator, Professor Mark Willoughby. Directly email Professor Mark Willoughby about your marks. Okay, this is one. Second, help hours. This week is the last week for lecture. So the help hour is follow the normal schedule. If you check the announcement, I have here, okay. In test 2 information announcement, you have a link about help hours. So this week, April 3rd to 7th, today is Monday. I just finished my office hours, okay? Tomorrow, Professor Huda is here at Mackenzie Chow 434. Those are in person from 2 to 3. And then on Wednesday, we have TA Chu Yuan from 11 to 1, and then Huda from 2 to 3. And we also have Professor Neil Marshall. He is responsible for all first year. This course is first year, so 3 to 4. Our last written assignment is due Thursday, so you have those half hours available. And today, I will happy to answer some questions about our last written assignment. As a matter of fact, I will give you some hints. Some students commonly ask questions. Okay. So this is the half hour for this week. After this week is the last week for lecture. After this week, we have the half hour during exam period. I just posted here, exam period, half hour. So just click this link. So this is MATH1p97. So I posted the wrong document here. I will show you the correct one, and then I will correct the mistake later. So those are the half hours during exam period. Okay. Some in person, some online, specific date and time. Maybe I'll try to, so maybe you can take a screenshot. Take a screenshot of this one. I will provide the correct one. So this is half hours for our final exam. It is scheduled on April the 20th. Okay. At 7 o'clock, it is online exam on web assign. Online exam. Okay, so those are some logistics. Any questions? Okay, now we go over the lecture, then I'll help you with written assignment 5. So today we just have one section, chapter 8, section 3, Maxima and Minima for functions of several variables. Please stop me at any time if you have any questions. The concept of maxima and minima is similar to what we did before for one variable. Okay. So I'll try to use an example to illustrate the graph to illustrate. So in this graph, if you look at this point, this is the relative maximum because this point is greater than all the points nearby, just nearby. So this is relative maximum. And if you look at this point, this is relative minimum because it is smaller than all the points nearby. And this point, this is a absolute maximum. This point has the largest value for all points. No points can be bigger than this point. This point is the largest. The absolute maximum, of course, it is also a relative maximum. And lastly, at this point, this is the absolute minimum. It is the smallest compared to all points. The absolute minimum is also relative minimum. Okay. And for this relative maximum, it is not absolute because you have a point larger than this one. This one larger than this one. So questions? All right. This finger shows that the point AB, so this point, you have x equal to A, y equal to B, and then z equal to FAB. And the slope of the tangent line to the surface is 0, as you can see here. So mathematically, if you take the derivative, partial derivative relative to x, it is 0. Take partial derivative relative to y, it is 0. So this, we have a relative maximum at point AB, means partial first derivative equal to 0. Those are possible relative maxima. And here, relative minima, you also have partial derivative equal to 0. So now we have conclusion. We conclude that a differentiable function satisfies both conditions, partial derivative equal to 0. And at this point, so look at this diagram, this is another concept. At this point, AB, FAB, so x equal to A, y equal to B, z equal to FAB. So here, if you take derivative relative to x, it is 0. Take derivative relative y, it is 0. And here we call this AB, FAB is the center point. So what is a center point? The definition. At the center point, F neither have relative maximum nor relative minimum. And this point is the center point. So this one is not relative minimum. This point is not relative maximum. This is the center point. The reason is some nearby points are higher, some nearby points are lower. So now, critical point of f is several variables. So critical point such that the partial derivative for x, partial derivative for y equal to 0, or at least one of derivative does not exist. Those are the critical points. This definition is similar to we had before for one variable. So now, how do we find relative extreme? First, find the critical point by setting the partial derivative equal to 0. And then do the second derivative test. Let d equal to fxx times fyy minus fxy squared. So I will explain what is fxx. Fx means take derivative, first derivative for x. The result, take derivative for x again. That is the fxx. For example, if I have f equal to x cubed plus y squared plus x 5. If this is my f, what is fx? Means take derivative relative to x. Consider y is constant. And then what is f(x)(x)? Take derivative of the first derivative again. Take derivative of this. So it is 6x. So this is f(x)(x). Okay? And now what is f(y)(y)? I will use the same example. So fy, so only take derivative for y, consider x is constant. So fy equal to 2y. Now what is fy? Means take this derivative again relative to y. Okay. Okay, last one is what is this fxy? So fxy, after you take derivative for x, then take derivative for y. But I do not have y, so it's just 0 for this example. So hope you understand the notation of fxx, fyy, and fxy. Questions? Okay, so once we get this D, so if D greater than 0, fx smaller than 0, it has relative maximum. And if D greater than 0, fx greater than 0, relative minimum. And if D smaller than 0, means fx has neither relative nor relative. Fx has neither maximum nor minimum. And this point is called Sandor point. When D is smaller than 0, it is Sandor point. And if D equal to 0, inconclusive, no conclusion. Any questions? Okay, let me check if there is question from online. Could you please repeat why fxy is 0? Thank you, Rutina, for your question. Why fxy is 0? Because fxy means take derivative for x first. So that is this one. And this one, relative, take derivative relative to y again. And this expression only has x, has no y. When you take derivative relative to y, but you don't have y, it is 0. So that's why fxy is 0. I give you another example such that fxy is not 0, okay? So let me give you another example, because this is important. So, So now let's do 3 important notation. Fx first. So means take derivative relative to x. This is Fx. And then Fxx and Fxy means for this one, take derivative relative to y. So relative to y, we have y here, okay? So it is 2x then 3y squared plus 3x squared. So this is Fxy. And then Fy. Look at the original expression, take y derivative. So y is here, y is here, y is here. So x squared, 3y squared. So this is Fy. And then Fy, maybe simplify. Fy. So this is y, this is y. Simplify. Questions? Sometimes we also have Fyx. Means take derivative for y first. It is here. Derivative for y. And then take derivative for x. So look at this. Do derivative for x. So you got questions? Okay, example. Found relative extreme. So what we are going to do, we want to find critical points. How do we find critical points? we set fx equal to 0, fy equal to 0. But first of all, what is fx? Take derivative for x, that is fx. Y is constant. And then fy, take derivative for y, relative for y, consider x is constant, so equal to 1. And now set fx equal to 0, fy equal to 0, you get x 0, y 0. Those are the critical points. After you set a critical point, we need to calculate dx. What is dx? Remember the formula. dx equal to fxx times fyy minus fxy squared. That is dx. So we need to calculate, this is fx, we need to calculate fxx. So it is just 2, right? And we need to calculate fyy, it is just 2. And the formula also said we need fxy. So we also need to calculate fxy. So fxy, take derivative for y, 0. Okay, and then calculate the delta d. Okay, what is d? D is fxx times fyy minus fxy squared. That is d. Fx is 2, fyy is 2, fxy is 0. So d is 4. And when d is 4, 4 is greater than 0. So you need to check fxx. fxx at which point? At the critical point. Remember what is critical point? Critical point, set this equal to 0. You get a critical point is 0, 0. Okay, so we need to calculate fxx 0, 0. So fxx at 0, 0. Because fxx is 2, has nothing to do with x. So it is just 2. So 2 is greater than 0, d is greater than 0. What do you conclude? Here. D greater than 0, fx greater than 0. So this has relative minimum at the point 0, 0. Okay. Relative minimum. Any questions? Okay. So the graph of the function, it looks like this. So it has minimum here. Okay, let's conclude our lecture part, very short. Any questions? And now I will go over our last written assignment, assignment 5. question 1 asks you to calculate. Maybe I want to make a notation to insert the file here. So that I can make a notation. Okay, so the question asks you to set up integral to find the area bounded by x equal to, this is parabola, and then x equal to y plus 1, this is a straight line. So find this shaded area. What is this area? Because the given is x equal to y, whatever y, this is x equal to y. So it is better if you turn, I'm not sure if you turn this into 90 degrees. Did you see? Not sure. No. So first, you solve for x and y, the intersection part here. Okay, from this graph, this one is 4. And here you got -2. So if you turn 90 degrees of this graph, so the area is from -2 to 4. And use this, the straight line is y plus 1 minus the parabola. Parabola is this. And then you do dy, not dx, and work out the final result. This is a simple way to do it. There are other ways to do it. So this is question 1 and question 2. Ask you to sketch the graph. The easy way, use dot graph. I already did that. So typing this expression and this expression. Okay. I'm going to copy this so that I can make a notation. This is these two graphs. Okay. So I ask you to calculate the area. So there are two parts. One is here. This is the area between those two curves. Another is here. Did you see it? And for the first part, this point is -1. This point is +1. And over here, you have this point is here, is 4. So -1, 1, 4. How do I get these 3 points? Do algebra. How do I get -1? How do I get 1? How do I get 4? Do this. Right? This equal to this. You'll get -1, 1, and 4. Okay. Okay, I'll move all the items to the right. So when you move all the items to another side, change the sign. Now collect like term. Now factor out, do these 2 items, factor out x2 minus, combine these 2 items, x minus 4. Then take out x minus 4. The second one is just x plus 1, x minus 1. So did you get those 4 numbers? X equal to 4, x equal to -1, x equal to 1. That's how you got those confirmed by the graph. Okay. See, you got those numbers, -1, 1, and 4. And once you are here, so what is this area? This area equal to from 91 to 1, then use the parabola minus the cube. So use the parabola. Parabola is 4 minus x squared minus negative x cubed plus 3x squared plus x. So this is this area. Always use the top curve minus bottom curve. Now let's figure out what is this area here. So this area is from 1 to 4. See, from 1 to 4. Use the top minus bottom. This time the top is cube. The bottom is a parabola. So you add those 2 integrals together, that is the area. So that is question 2. Question 3. Last class we did trapezoidal rule. So what is this rule? The Maxima error, it said m times b minus 1 cube 12n squared. So b equal to 1, a equal to 0, as indicated here. This is B, this is A. And what is M? M is the second derivative. Smaller equal to M. Our objective is to find this M. Once we found this M, we can calculate this expression. So the purpose is to find capital M. To find capital M, we need a second derivative. To find the second derivative, we need the first derivative. So this is fx. The first derivative, it is just this. Right? And the second derivative, take derivative of the first derivative. So it is just this. Okay. And remember, what is the range for x? X is changed from 0 to 1. X from 0 to 1. So write it down. X from 0 to 1. This is x from 0 to 1. It is set here. Okay, it's here. If x from 0 to 1, every item you use this ex smaller than e1, easy. It still holds true. And then I will use 1 over each item. This time, it will be changed. It should become this. Okay. And the middle one here, it is just e negative x. And what is this e negative x? It is just second derivative, see? Second derivative equal to e raised to power negative x. So second derivative is between here and here. And take a look at this part, what this tells you. Second derivative smaller equal to 1. See here, second derivative smaller equal to m. Did you get what is m? M is 1. Look at this one here. We are looking for m. You found it. Second derivative smaller than m. Similar structure we did last class. Take a look example of last class. We did similar strategy. Found m. Once you found m, this is a piece of cake, right? So 1. B is 1, A is 0, N, what is N? N is 8. Then you figure out what is this number. That is the final answer. Question 4, very easy. You just plug in x. I will randomly do one question. Just give you the hint. Okay. Find f e1. So F(E1) means X is E, Y is 1, X is E. And long 1 equal to what? So if you don't know what is long 1, Excel. By the way, final exam, Excel is allowed. Excel is considered as calculator. Do not use Excel other functions, just use Excel for calculation. Okay? So if you forget what is long 1, so equal ln1, 0. Long 1 equal to 0. So E times 0. What is long E? It is 1. Final result. I just give you example here. You do other items. Okay. And question 5 looks complicated, but is very, very simple. So the current dividend yield is this formula. D is the most recent 4-year dividend. P is the current share price. Next, you are given annualized dividend for the year 2019. So this one, annualized means 4 year is $4. So means D is 4. And the share price was this, 197 means P is 197. The question asks you what was the current dividend yield at the time. You just plug in those numbers. Okay. Question 6, found the first partial derivative. Means found what is fx, what is fy. First partial derivative. Okay, you do it. Okay. And this one found fx, y, fyx. We did another example, question 7. And question 8. For question 8, so question 8, chapter 8. Go to example 4, exactly the same question. Okay, I will show you. Yeah, this one here. So this is the example. The question is exactly the same as this example. They just changed the numbers. So I just refer to here. So you are given the revenue function. Oh, not this one here. Let me see. Should be section 3. So anyway, the question is example 4, cost and revenue. Exactly follow that example, you will be fine for that question. I couldn't locate. I should write down the page number. Okay, so that is the only hint I gave you. See example. Four in chapter 8, section 3. Exactly the same question. Revenue function, cost function. Okay. Okay, any questions? For final exam review, unfortunately, there are no materials available right now, but I will post material. I will email you review material through email for final exam. Okay, by tomorrow. By tomorrow, you'll get my email containing materials review, just an idea. Okay, review questions for final exam. Okay, and make sure you utilize the Mathematics Learning Center this week. Okay, as well as the half hours. Okay, so let me take a look at online questions. For question 2A, for question 2A, does the graph have to be hand drawn? Can we submit screenshot? Could be both. Any other questions? Okay, I would like to take this opportunity to thank you so much, both online participation and in-person participation. Thank you throughout the semester. Good luck on final exam. Any questions? Go to Mathematics Learning Center or email me for specific questions. Okay. That's all for tonight. Thank you so much. Good luck for final exam. All the best.
Is the final exam online or in person?
Online. Final
So
exam
just
online.
like at home?
Yeah, like test 1, test 2.
Because when we go to my bra, it says it's in the gym.
They changed. I will show you.
Okay.
I will confirm. They email me, they will change.
Mm-hmm.
So I will double check. Block you. Menu, registration. Then exam. Why it is here? I don't look for important dates. I looking for Our final exam is online, okay?
Okay, I did.
So ignore the website posting on
Yeah.
gym, ignore that gym information. But they told, they emailed me, said they'll change it.
Okay. All right. Thank
Okay.
you.
Thank you.
So yeah,
Okay.
it's the 20th, 7 p.m.
Yeah,
How many questions are on it?
I don't know, sorry.
Oh, you don't know it?
Yeah,
You didn't make it.
I don't make it. Our coordinator, Mark Willoughby, he makes it.
Oh,
Okay.
okay.
Okay, let me, the question for the Maxima. Okay.